The Netherlands, famous for its windmills and tulips, is a global pioneer in carbon neutrality. In 2023, 48% of electricity produced in the country come from renewable sources such as solar, wind, and hydropower. However, the power grid in the Netherlands faces unprecedented challenges such as insufficient capacity. The electricity tariff is negative for 30 years each year on average. It will be the time-consuming and costly to revamp the power grid, which restricts the development of renewable energy and charging networks. In this episode of Carbon Talk, we will explore how the Kronenberg campus in the northern Netherlands deployed the first project that used the Optimizer+PV+ESS and charger integration solution in Europe to address such challenges. Nice to meet you, Ernst.
Nice to meet you.
I know this project is Europe's first optimizer solar panel and battery, and also the EV charge. So would you like to introduce the background for this project?
Thank you for this question. We were forced by due net congestion. We only received like a very small grid connection, only 55 kilowatts. As engineers calculated that we need over 200 kilowatts. So that was for us a trigger to solve and to build the energy system of the future. And we were very happy that we can have the 4-in-1 solution from HUAWEI. So the optimizers with PV installed over 88 kilowatts, and also 2 batteries of 400 kilowatts in total. And as a cherry on the pie, we also add a charging cabinet of 600 kilowatts, where we can do some fast charging with our cars, company cars.
Just now you mentioned about the congestion of the grid. It's a normal phenomenon in Netherlands.
Yeah.
Do you discuss with the grid? Maybe you can enlarge the capacity for the grid.
We just were declined about our 200, 3 times 200 amps. In this area we have to wait, I think, over more than 7 years for enough capacity.
7 years.
7 years, yeah.
If the grid modernizes the capacity, how much money you will pay if you?
Well, I can pay them, but I don't know when they are going to. If you want to know some numbers, it's around 40,000-50,000 euros.
Yeah. I think this is the normal pay point for all the campers, for all the owners. Even in China, we still need at least 1 year to modernize your grid. But in Europe, today you told me 7 years is quite long.
Yeah, in this area.
In this area, it's quite longer.
Yeah.
Let's go to see the product and the solution.
Yeah, we will. Right now we are in front of the Luna 2200 kilowatt hours. We have 2 units here next to each other. Each unit is good for 200 kilowatt hours, which makes it a total of 400 kilowatt hours in battery capacity. And each battery unit has a 100 kilowatt inverter, basically, which means that they can fully charge and discharge over a time of 2 hours. Next to that we also have the charging dispenser right here. Here's all the hardware for the charging points interact together with the building, the PV and the batteries to make sure that we can put as much renewable energy inside of the cars as possible. I know that many customers care about the safety when they buy the battery. Safety is the first priority they would like to consider. To be fair, this battery has been designed with first safety in mind, and then the rest came along. So something that also not a lot of people know about HUAWEI is that HUAWEI has been making batteries for over 20 years out of the telecom industry. So we're not new at this, and there's a lot of experience that has been grown over those 20 years in safety features that are inside. It's constantly monitored by all these sensors to see what is going on. If one cell is acting weirdly, then it should be shut down, also with the optimizers. So there's all these layers in safety within sensors. One feature that I didn't even mention yet is overpressure doors. On top of, basically we are the first one that has this incorporated in a battery. Should a cell at some point go in from a runaway, a lot of pressure, a lot of gases are released. And if you don't have a safe way to release those gases, the doors will come out. A few months ago in Germany there was such a case, not with HUAWEI battery. Firefighter did get hurt opening the door and then the door blew away. So these are things that we need to take into account with, for example, these pressure vents. So if there should be too much pressure, the firefighter wants to open it, the pressure will be released on top and not in front of his face.
The important thing is we don't hope that it happen, but when it happen, it can guarantee the safety for your maintenance guys. So I also heard that for the solar solution on the rooftop of this building, you also use the optimizer. Why you choose the optimizer at that time?
We wanted the highest yield as possible. You can get like 3-4% more yield. Normally when you have a flat roof you don't use optimizers.
Yeah, sure.
But actually when you go to the roof and you see all our installations on the roof, you also see some shadow. And that was also
influence
the yield.
Yeah, sure.
So that's also why we advise to use optimizers.
How about give us the very simple introduction about the EV charger?
Yeah, sure. This is basically the box where all the magic happens inside. It has a maximum of 720 kilowatts and DC power output. It's a liquid cooled system, which makes sure that it is as quiet as possible and as efficient as possible. So next to that, it's also a decentralized system. So you have units, the DC-DC converters inside are units of 60 kilowatts, which you can allocate to one specific output. But should you have one car which needs, for example, 200 kilowatt, you can allocate that X amount of DC-DC converters to that car and put less DC converters in another car, or you can optimally change it. And this is because the loading curve of a car is not always constant 200%. Maybe it does 200% the first 10 minutes and then it goes down to 150 or 100. So that means that as soon as one DC-DC unit gets free, you can use it for another car.
And it gives you, for example, like almost 30% more utilization.
How many years for the payback or the return of the investment normally?
Actually, we have chosen for the power cabinet because we saw some availability in the battery. So our return on investment with only batteries was around 4 or 5 years. Okay. With charging cabinet, it can be you can bring it back like 3.5-4 years.
That's quite a good business. What do you think about this product?
Before we started building this building, we had a talk with a lot of other PV and battery companies. It's not only the product, but it's the total branding of HUAWEI. It's the quality, it's the after sales, it's the one person in contact for everything. Okay. Those are very important things for us. And also it's very easy to integrate with a third-party EMS. Okay. That's also very important.
Okay, thank you. Thank you, Ernst. In the Kronenberg project, the PV+ESS solution effectively solves the problem that the charging network cannot work normally due to insufficient power supply in the campus. Moreover, the solution implements flexible energy dispatching and response to participate in electricity market adjustment. It maximizes the benefits of energy storage and provides a valuable experience for installing PV, ESS and charging network in campus. We believe that innovative practice in the Kronenberg will set a good example to drive the green, electrical, and intelligent development of the campus on the way to the carbon neutrality. Thank you for your time. Stay tuned for our next episode.